Hey everybody, I thought I'd show a quick update what's going on. It's got a bit noisy because of the pulse motor. It's running almost at its full maximum. It's kind of where I'm at with the jig for the bottom side of the pulse motor. The top pulse motor still got a lot of work to do, and as mentioned in the earlier videos, it's going to have a self-sustaining system going on here. But I'm working at the base, and this is kind of the configuration of where I've laid out. So you're familiar with the driver circuit. The output of the driver circuit gets connected to these two 16.6 volts at 350 farads, both connected in series, which the wiring gets fed through the switch, and the switch gets connected to the 500 watt DC to DC boost converter. The lead kind of travels around there and gets connected to the 100 watt DC to scooter motor, so 100 watt scooter motor, and it's got a coupler which is just duct tape just to test it out, which is connected to a supposedly 600 watt permanent magnet generator or an alternator, but it's called that way for some reason. It doesn't really produce 600 watts as the advertisement states, but it's roughly at its most maximum RPMs. It could probably produce somewhere around 200 watts. It's a three-phase permanent magnet alternator generator that gets wired to a three-phase diode configuration. The diode gets fed through this meter, and the meter is connected through the output of the two 40 volts, 68,000 microfarads. As you know, when you add it in series, the farads get divided and the voltage increases, and the output of that, just to have a load, gets fed to another 100 watt DC scooter motor. And as well, utilizing the mechanical energy and having these pickup coils, I've got another big one behind that rotor, just kind of sitting at the back, and the small one there's connected in series. I've ran out of wires for me to properly solder it all the way, so I'm just going to make do what I have. And this is connected to a triac little circuit, which kind of cleans and stabilizes the frequency for the lighting so it doesn't overly flicker, to a 100 watt LED light flow. So I'll just show you where I'm at. It's not completely done, so you're not going to see over unity, but you're going to see some potential of over unity effects. So yeah, all right, let's do it. Let's connect leads. That running that quite brilliantly. Now I'm going to hit the switch to that and watch this motor and the sludge go. So that's the output wattage, voltage and amps. It's going to fluctuate, it's going to stabilize, but still incredible amount of power. Still getting a lot of luminosity in the light. The rotor slowed down a bit, but it's giving a lot of generation of power. But as you can see, it's not full over unity, it slowly dies off, but it's just got a lot of potential there. So hopefully once I get the top system going, then maybe it can help assist this system. And this is real juice here, you know, and it's quite dangerous if you don't know what you're doing. So anyways, I just thought I'd show you that quickly, and yeah, speak to you next time.